So what are the inventory control problem? The resources that are kept for future use are called as inventory. These may be of any type, goods, men, machines, etc. Generally, these problems arises where some product is sale or some product is manufactured. That is like shops and factories, etc. There are some inventories kept for the future use. That is, if demand is high and supply is not appropriate, then some quantity of product should be maintained so that supply or sale can be done uninterrupted. So the inventory is an ideal resource, but it is essential to maintain some inventories for smooth functioning of enterprise. The problem related to how much inventory should be maintained and how much order should be placed is called as inventory control problem. Why inventory is needed? Inventory defend the enterprise against two type of loss. One is called as current loss, other is called as future loss. For example, a person goes to a shop to purchase an item but that was not in the stock. Then he returned empty hand and the shop is from the shop and it caused the current loss. If persons returns empty handed twice or thrice from the shop, then he could think that shop is not good and he can move to another shop, which causes lots of goodwill of customer as well as loss of money in the future. To avoid such kind of situations, inventory is maintained. Now, costs associated with inventory. There are several costs which affect the inventory, among which main are: number one, setup cost. It is the cost of setting up the machinery before the starting of production. When you place order and the product should be manufactured into the some factory, then he start the processing, for which for starting the processing he needs some money. That money is called as setup cost. This cost is generally independent of size of an order. That is, it does not depend upon the size of order. It is independent charges and always occur when order is placed. Second is ordering cost. It is the cost associated with the ordering of raw material for the production process. It also includes the costs related to advertisement, stationery, postage, transportation, etc. It reduces when the size of order is increased. Like if you buy one piece of soap, then it will be of cost rupees 20, and if you buy the pack of three, then 5 rupees will be deducted, that is you will get 50 in rupees 55. That means per unit cost will become around 18 to 19 rupees. That's how ordering cost reduces with the size of increase in the size of order. Third cost is inventory carrying cost. If product is stored in large quantity, then some cost also required for maintaining that inventory. It is also called as holding cost. It includes the cost like rent of place, insurance of stored equipment, taxes, etc. If size of order increase, then inventory carrying cost also increase. Next is shortage cost. Shortage cost is a penalty cost for running out of stock. That means if you have no stock, then you have two type of losses. I have already told. One is loss of current profit, and second is loss of goodwill and future profit. So that are included in the shortage cost. Next cost is purchase cost. Per unit cost of purchasing of an it is the per unit cost of purchasing an item. The purchasing cost would be important when quantity discount are allowed for purchase above a certain quantity. That means if you buy 50 products, then cost will be different. You buy 100 units of the product, then cost will be different. So in such manner, these are called as the case of price break, in which purchase cost is important. Other than cost, there are certain more factors which affect the inventory. These factors are as follows. Demand, the number of units required per period of time is called as demand. The demand pattern of a commodity may be either probabilistic or deterministic. In our lecture, I consider only deterministic problems. So you have heard that ice cream requirement of ice cream is higher in the summer, whereas in winter it is ice the quantity of ice cream required is smaller as compared to summer. So demand varies with the time. Second is lead time. Lead time is the time gap between placing an order and its actual arrival. That means if you order some goods, then it is available upon ordering, then it is called as lead time is 0. If there is a gap, then it lead time will be some quantity. Third one is time horizon. Time horizon is the period over which inventory level will be controlled. It may be finite or it may be infinite, but generally it is taken as 1 year. Next factor is stock replenishment. Stock replenishment means the restoration of a stock or supply to a formal level or condition. That means first stage I have ordered 50 units of the product, then some units are sold, have remained 15 units, then I order 35 units. That means it total items will again reach 50 units. So that is the stock replenishment. The stock replenishment is of two type. One is called as instantaneous and other is called as uniform. When product is manufactured by the company, then it is called as uniform replenishment, and if it is purchased from outside, then it is called as instantaneous. Next is order cycle. So order cycle is the time period between placement of two successive order. The new order is placed by reviewing the inventory. There are two methods for reviewing the inventory. One is called as continuous review, other is called as periodic review. Under continuous review, inventory level is checked continuously until it reached to a specified level. When inventory reaches to a specified level, then new order is placed. And in periodic review, inventory level is checked at equal time interval and order is placed at such intervals. That is, on each such interval, a new order will be placed. Next is reorder level. The level between maximum and minimum stock at which new order is to be placed is called as reorder level. The next important thing for inventory control problem is economic order quantity. The order quantity specifies the number of units ordered or produced during a single production cycle. The process involves two type of opposite cost. One is called as ordering cost and other is called as inventory carrying cost. Ordering cost decreases with the increase in the size of order, whereas inventory carrying cost increases with increase in the size of order. So therefore, if large quantity will be ordered, then inventory carrying cost will be large. And if a small quantity will be ordered, then ordering cost will be large. Therefore, the order quantity must be decided in such a manner that the total cost will be minimum. That means neither of two costs, that means neither of ordering cost nor the inventory carrying cost must be too much high. The quantity which minimizes total cost is called as economic order quantity. It can be explained with the help of this graph. Here, two axes. On one axis we take quantity and on the other axis we take cost. Generally on horizontal axis quantity is taken and on vertical axis cost should be taken. Then ordering cost decreases with the size of order. That means if quantity increases then ordering cost will decrease. So it is the curve of ordering cost. And inventory carrying cost increases with the increase of ordering cost. That means if number of quantity increase then or inventory carrying cost increase, so it will be inventory carrying cost. The total cost, since here is a sudden decline in the ordering cost, so total cost first decreases, then when ordering cost become stable, it start being stable, then total cost become increasing. That is total cost curve comes like this. So here you can see this point is minimum. From this point we draw a perpendicular to the axis of the quantity, that is this one. Here, this at this point, the perpendicular intersect the axis of quantity, and this point will called as economic order quantity. And if we draw the a perpendicular from same point to the axis of cost, then we would obtain total minimum cost, or you can say minimum total cost. Here you can see another thing, that when we order the economic order quantity, then ordering cost and inventory carrying cost both are equal. Now different types of inventory problem. So inventory problems can be divided into two different types. One is called as deterministic inventory problems and other is called as probabilistic inventory problems. Since I have considered only deterministic, so I am not going for the classification of probabilistic. Deterministic can be further divided into two parts: without shortages and with shortages. The inventory problem without shortages are generally of two types. One is fundamental EOQ problem and other is EOQ problem with finite replenishment. Or you can say EOQ problem with finite rate of replenishment. Fundamental EOQ problem is also called as EOQ problem with instantaneous production. In same manner, with shortages, inventory problem is also two types: EOQ problem with instantaneous production and EOQ problem with finite replenishment. Now, for further, some notations will be used. First one is D, that is total number of units purchased per period of time. Generally, that period of time is taken as 1 year. Q is the lot size per production run, that is number of units ordered in one order. CS is setup cost per production run. When a new order is placed, setup cost will be also chargeable. C1 is per unit inventory carrying cost. C2 will denote the per unit shortage cost. T will be the length of one production run. N will be the number of production runs per period of time. So period of time is taken as 1 year. So we can say N into T is equals to 1. And Q naught is economic order quantity or lot size that minimizes the total cost. Also D is equals to N into Q. So what is the fundamental EOQ problem? That is also called as EOQ problem with instantaneous production without shortages. The objective of this problem is to determine economic order quantity in such a manner that total cost is minimized for under certain assumptions. These assumptions are: number one, demand is known and uniform. That means throughout the year demand does not change, like soap or other things or rice or wheat, their demand never change with the time. That will remain uniform. Number two, production of commodities is instantaneous. That means product is purchased from outside. Third assumption is shortages are not permitted. That means as soon as inventory reaches to zero, new order is placed and that will be available upon placing the order. That means fourth assumption, that is lead time is zero. Fundamental EOQ problem can be explained with the help of following graph also. Here on two, there are two axes. On horizontal axis I have taken the time and on vertical axis I have taken the inventory, or you can say quantity that is ordered. At first stage QI units will be ordered, then with the time it should be sold and it started decreasing. So it start decreasing and up on decreasing it will hit zero level at some time point. Then at this time point again a new order, again a new order will be placed and that will be available immediately upon ordering. Then again q units will be become available and it again started consuming. So in such manner, fundamental EOQ problem can be explained and the time gap between two successive order is denoted by T. And Q by 2 is called as average inventory. Now how we obtain the total cost and how we minimize it. So in this model, it is assumed that after each time T, a new order of Q quantity is placed throughout the entire period of 1 year. If n is the number of time order placed and t be the length of production run, then n into t will be 1 and is the total demand, that is the number of units required in 1 year. So n into q will be equals to d. Now what will be the total inventory during the period of time t? So you can see here in this graph, at a particular time, at zero time, quantity is q units. After some time it decreases in such manner, that means some low then q, then again it decreases, and next time point it also decreases and so on. So we can say that the total inventory will be this one. That means the area of the triangle OAB. So it is a triangle, its area will be half into length into height. That means q into t by 2. So total inventory will be q into t by 2. Average inventory, that will be total inventory divided by total time. That means q into t by 2 into 1 upon t. That will give q in q by 2. The average inventory in each interval of period T will remain Q by 2. So we can say that throughout the year, the inventory level will be same, that is Q by 2. Now annual inventory carrying cost will be per unit cost, per unit inventory carrying cost, that is C1 into average quantity or average inventory, that is C1 into Q by 2, that is Q into C1 by 2. The annual setup cost will be per unit setup cost, that is CS into, sorry, cost, setup cost per production run, that is CS into number of productions run into, that is CS into N. And we have already described that N into Q is equals to D. So N can be replaced by D upon Q. So annual setup cost will be DCS upon Q. Setup cost is denoted by GQ and inventory carrying cost is denoted by FQ. So total cost will be FQ plus GQ. That means Q into C1 by 2 plus DCS upon Q. Now we minimize the total cost with respect to ordered quantity. So apply the condition of minimization, that is partial differentiation of total cost with respect to Q will be 0 and second derivative should be larger than 0. On minimizing the total cost with respect to Q, it is obtained that del Tc upon del Q is equals to 0, implies that here you can see total cost is Q C1 upon 2. So we differentiate it. So it will give C1 upon 2. And second term will be differentiated with respect to Q. Then it will give minus DCS upon Q square. So first derivative will become C1 upon 2 minus DCS upon Q square, which will be equal to 0. On solving it, we would get Q naught is equals to root 2 DCS upon C1. Since it is quantity, is on square root, we can get two solutions, plus and minus, but it is a quantity, so we consider only plus sign, minus sign is ignored. Now we double differentiate the total cost, then it will give DCS upon Q cube. Sorry, 2 DCS upon Q cube. That means derivative of this term will become 0 and derivative of this term minus 2 will be multiplied and power of q will become 2 plus 1, that is 3. Now since D is positive, it is a quantity, CS is cost, it cannot also be negative, and Q naught is also, I have taken the plus sign, so this square root is plus. So all the quantities are positive, so is cube of Q naught will also be positive, and since all quantities are positive, the value of second derivative will be greater than 0. That means Q naught minimizes the total cost. So the economic order quantity is root 2 DCS upon C1. Further, some characteristics can be obtained for the problem. First characteristic is the minimum total cost. So in total cost, we replace Q by Q naught and put its value, that is root 2 DCS upon C1, and solve it. Then it is obtained that minimum total cost is root 2 DCS into C1. Then how many numbers of orders should be placed during 1 year? Then it can be said that N naught is equals to D upon Q, that is D upon root 2 DCS upon C1, which will give root DC1 upon 2CS. That is the optimum number of orders placed per year. And optimum length of time between two successive orders. So N into T was 1. So T naught will be 1 upon N naught, that is root 2 CS upon DC1.